Hey everyone, welcome to hok'stutoring. I hope you are doing well and enjoying the start to the school term, or if you're just watching this video mid-year as a review, then I hope you are progressing well in your math studies. Well, in the last video, we went through the differences between a relation and a function, and I just thought I wanted to derive or delve a little bit deeper into the different types of functions that there are. So in the previous video, we used two adjectives for a function. We had one-to-one, and then there's also the many-to-one function. Well, surprise, surprise, we've got more adjectives to add to a function. So in this video, we'll go through three of them. We've got an even function, we've got an odd function, and then you have a function that is neither even nor odd. So without further ado, let's get into the video. Okay, so first of all, I will give you guys the algebraic definition of what an even, odd, or neither function is. For an even function, if I was to substitute a negative value into a function, then if I get the same function as if I was to sub in a positive value, then that would be an even type function. An odd function, same thing again, if I was to sub in a negative into a function, then I will get a reflection, or in this case, if I was to sub in a positive value, I will get the same value as this, but with a negative in front of it, okay? And then a neither function is if I was to sub in a negative value, I wouldn't get the same function, or at the same time, I also wouldn't get the reflection or the negative or the reverse of that same function, okay? So then you get a neither. Right, so algebraically, there is that definition to help you. But then to further understand the types of functions that we have here, it's best that we illustrate this, or we try to picture it in our mind. So before I do that, there is one key test that you need to do every single time to determine whether a function is even, odd, or neither. And I will write that down here and make sure you remember this. So the key test here is the reflect upon your y-axis. Okay, so reflect upon your y-axis test. And this is just something I made up. You probably won't hear it from your teacher, but if you want to determine whether a graph, any type of graph that you've been given, is an even, odd, or neither function, then the one single test that you just have to do is reflect the graph upon the y-axis. Okay, so we're going to go through all of it here and you'll see what I mean. Right, first example of an even function, I will draw a parabola. So parabola obviously have the equation y equals to x squared. Now you might see this power here is 2, and you're like, oh, degree power of 2, that's an even number, so surely it has to be an even function. Well, you are right, but that is not the right mentality to go through it, or not the types of strategy that you want to be using when determining whether something is an even or an odd or neither function. I'll show you later on why y equals to x squared or a degree power of 2 or 4, an even function, doesn't necessarily mean it's an even function, okay? So let's do the reflect upon your y-axis test. If I was to reflect this graph upon the y-axis, so that's the y-axis over here, then what graph do I get? Well, if I get the same graph, and excuse my terrible drawing, but if I reflect this graph right here, I essentially still get the same graph. And if I was to do it algebraically, then you can also see it right here. If I was to sub in negative a, right? Negative a squared. Well, we know that negative a can also be written as negative 1 times by a, and then the whole thing square, okay? And what essentially you get is negative 1 square, a square. Well, negative 1 square we know is 1, because negative 1 times negative 1 is 1, positive 1, and then a square is a square. Well, a square is essentially the same as subbing in just fa into your graph, right? So that is the same as subbing in fa. So that's what you get. F negative a still gets you fa, therefore this function, algebraically, graphically, we can all see it is an even type function. Now, let's move on to the next type of function. We've got an odd function. So an example of an odd function, I'll just give it right here, is a simple one, a cubic graph. So y equals to x cubed. Now, if I was to, again, apply your reflect upon your y-axis test. If I was to reflect this upon the y-axis, so again, reflect it upon the y-axis, what graph would I get? Well, this side right here, imagine there's a mirror, would come over here, and maybe I'll just do a better drawing at that. And then this part down here would just reflect onto this other side. So then you get this graph, okay? Now, to determine whether something is an odd function, you also have to reflect it upon the x-axis. So I'm going to try reflect this cubic graph onto the x-axis. So I also do it this way. So I do it that way, and I bring it that way. So what I get, if I was to reflect it, is this part, section right here, comes up, and then that section right there actually goes down, and that should really be flat. But what you can see is if I was to compare this, okay, so this was reflected upon the y, and this was reflected upon the x-axis. If I was to compare these two graphs, you will see that they are actually the same graph. And that is exactly what an odd function is. If I was to reflect this upon the y-axis, and it's the same as if I was to reflect it upon the x-axis, then that is an odd type of function. And I guess to illustrate that example, and I might have to just squeeze it down here, is if I was to sub in y equals to negative a, and then put that in a cube, because our function is y equals to x cubed, then what I get is negative 1 times by a, and then the whole thing is cubed. No, negative 1 cubed is negative 1 times negative 1 times negative 1, and I actually get a negative value, negative 1. And then you multiply it by a cubed, and you get negative a cubed, which essentially is the same as saying f of a, which is x cubed, okay? So f of a is x cubed, but I put a negative in front of it, so that becomes negative x cubed, which meets this definition right here, because that is negative f of a, okay? So if I was to sub in a negative a, and I get a negative f of a, that is an odd function. Right, let's move on to the next type of function. We've got a function that is neither even nor an odd. And here's where I'll show you, guys, where you shouldn't be relying on your degree of power. So if you see an x squared, for example, then that doesn't always necessarily mean it's an even function. Or if you see, x cubed, that's an odd number, an odd power, so that has to be an odd function. Well, not necessarily, because have a look at this. If I was to get this graph, y equals to x plus 1 square, okay? So this is a parabola, power of 2, that's being translated 1 unit to the left. Okay, again, apply your reflect upon your y-axis test. If I was to reflect this upon the y-axis, so right there, what would happen to my graph? Well, this graph would then just shift over to this side right here. And if you have a look now at the rules of an even and an odd function. So a rule of an even function, you reflect the graph upon the y-axis, you get the same graph. Well, is this the same graph? No, it's not, because now this graph has shifted all the way to the other side. So it's not an even function. We can rule that out. Even function? Nope, none of that. Now, is this graph an odd function? Well, to test whether something is an odd function, you also have to reflect the graph on the x-axis. And if you reflect this graph on the x-axis, we know for sure it looks like this. And this graph right here, this is reflected upon the y, that is reflected upon the x. They do not look the same at all. So because these two graphs are not the same, then it is not an odd function. So if it's neither an even nor an odd function, then you have something called a neither. So it's neither even nor odd. Essentially, that's what it is. And algebraically, again, if I was to sub in this graph right here, so if I was to sub in a negative a inside the graph, as opposed to x, so in place of x, and I put a square on top of it, well, that is not the same as a plus 1 square, and at the same time, it is not the same as a plus 1 square with a negative on the outside. And you can test this out. You can imagine if you were to expand it, you wouldn't get the same graph, okay? So guys, that is it for these 3 adjectives that you can now add into your dictionary of how to describe a function. You've got an even, odd, or neither. Well, I hope you enjoyed the video, and if you did find it useful, please leave a thumbs up, and I will see you in the next video. Thanks for watching.